The next thing that we are going to look at is Kirchhoff's second law. Just like how the first law was simply a consequence of conservation of charge, the second law is a consequence of conservation of energy. Then I am hearing your mind voice. Then what's the point of Kirchhoff? What did he invent for the first time? Well, he didn't discover much, but he discovered much in the sense that it is he got these laws from experimental point of view, and later on when we had a better understanding of charge conservation and energy conservation, we understood, okay, basically these are coming from there. So I want you to remember that at this point that current, the phenomenon of electricity, was discovered way before we had any understanding about charges. It is from Millikan's oil drop experiment, that beautiful experiment, that we found the charge of an electron and we found the quantized nature of electric charge. So before that, we were thinking so wrongly, so much so that we were even wrong about the direction of electric current. You understand what I'm saying? So Kirchhoff's law should have been discovered or put forward at a time before Millikan's experiment. Then only it makes sense to give credit to Kirchhoff. Otherwise, I don't feel that, like, if it is simply a consequence of this, what's the point? Now, there is actually a whole discipline of a whole new subject area called the history of physics. There are actually three things: physics, philosophy of physics, history of physics. And do you know that physics actually originated from philosophy? Greek philosophy then slowly transformed into physics. So there was a time where philosophy had its golden age. There was a time where physics had its golden age, and now is the time for the golden age of microbiology. Yeah, I think. Okay, so you feel like so I'm thinking that this law, this Kirchhoff's laws, which are simply consequences of two fundamental other laws, should have happened at a time before Millikan's experiment, but I'm not sure. So just try to Google, and also when you're Googling, Google about this history of science, history of physics idea as well, and let me know whether it is the case. But the law is very simple. It says the sum of electromotive forces in a closed circuit is equal to the sum of the potential differences. Now, yeah, you already know that there's nothing much difficult about that, but the thing is to solidify the terminology. Now, in common language, it is like we used to say that the potential difference of the battery. But if you want to be technically correct, if you want to be very, very skeptical, then to say potential difference of the battery is a wrong thing. Because we say potential difference when energy is converted from the form of electrical to some other form, electrical to light, sound, movement. But in a battery, the form of conversion is from some other form to electrical. So, strictly speaking, it is not correct to use the term potential difference of the battery. So when you're talking about the potential difference of the battery, you have to say EMF of the battery. And as I said yesterday, don't be confused about the force thing, electromotive force. Though it is called a force, it is not a force, it is energy per coulomb, it is voltage. So when you're talking about the voltage of a battery, you have to say EMF. And the other thing is that because of this force word confusion, we have dropped saying electromotive force, and the short form EMF stands as a term in its own right. So that's one thing. Then when you're talking about the components, to say that the EMF of the components, of course we don't say that much, but again, if you, what I'm trying to say is you can't swap these terms. So when he is saying that the sum of the electromotive forces in a closed circuit, that means he is saying, now if you replace that word electromotive force EMF as the sum of the energies converted to electrical form, the sum of the energies converted to electrical form to give, that is given to 1 coulomb of charge in a closed circuit, is equal to the sum of, now replace the word potential difference, is the sum of the energies converted from electrical to other forms in a closed circuit. So what is given is taken back. Okay, so it is simple conservation law. So the sum of energy is given is, for since we are talking now, is voltage is when you are talking about energy that is given for a unit charge. So E is the energy given. Now that becomes the energy of that unit charge which it spent on the lamp and then the resistor. So if the voltage drops are V1 V2, it sums up as E is equal to V1 plus V2. E is equal to, now you can substitute for V1 V2 as IR1 I2, so IR1 plus I2. It's basic, but the thing is you need to remember is this order: EMF from some other form to this one, electrical. Potential difference is from electrical to some other form. Okay, so that's one thing.